We're at part 2 of section 2.1, and we've learned about a frequency table. We're going to expand that concept into the area of relative frequency. The idea of relative is a proportion of a decimal or percent, relative frequency distribution. So this means that we're looking at the effects of a frequency table in terms of a percent, a portion of. And of course, it is frequency. So what we're going to be having is our N, which is the total sum, or the total frequencies. And we're going to have our interest, and that would be our frequency per class. Now, this is easy in the sense that we're going to do the mathematics on the home screen. Construct. And we're going to be looking at our percents, where we take the ratio. This is the relative frequency. But then if we multiply by 100, we get the percentage. And in this homework that you're going to be doing, we have that condition occur. Now, because use rounding rules, total of 100% can vary slightly. In other words, we might have 99.9% or 100.1% or any variation of that because of the rounding principle. And I wrote here what the textbook had. The sum of the percentages in a regular frequency distribution must be very close to 100, with a little wiggle room for rounding errors. And they're not really rounding errors. They're just the way the mathematics defines where we put as a value on that 100%, on the idea of that. So let's do an example of finding relative frequency. All right, so the very first thing we have to do is find total frequency distribution. All right, so I'm going to bring down my calculator. I'm going to clear everything I worked on before. I'm going to draw my line here, and I'm going to add all of those values. Oops. Okay, now remember, when you make a mistake, you just go back and put the 3 and enter. I'm going to check 5, 15 twice, 4, and 3. So the total is 42. So now I'm going to construct each of the small problems. All right. What you're hearing is, if you hear anything, it's my puppy playing. All right. So we're going to put the 5 over the 42, the total, times 100 to get the percent. On this one, we're going to do the 15 over the 42 times the 100. And this one is going to be the same one, so we're going to work this one once. That's always nice. It's the 4 out of the 42 times that 100. And this one is the 3 out of the 42 times that 100. All right, so now we're going to get our calculator back and figure it out. So I'm going to have, remember, let me write that down. A fraction is undone division. So what we're saying is it's a numerator over a denominator. It's a numerator divided by the denominator. All right, just making sure nobody gets lost in the shuffle. So we're saying 5 divided by the 42 times that 100. And remember, the calculator that I've asked you to purchase does order of operations. So we have this number here, 11.904 dot dot dot, and we want one decimal place. So we're going to say that this is, and I'll move it over just a tad, 11.9%. All right. So now we're going to do the 15 divided by the 42 times that 100. And I'm going to get 35.714 dot dot dot. And we're going to round to one decimal, so that's going to be 35 7/10%. Now this one's the same. So we've got that. Now we're going to do this one, the 4 divided by the 42, and I get this number. Oops, I'm sorry. Let me try that again. 4 divided by the 42 times the 100, because we want the percent, and that's going to be a 9.52, oops, sorry. 9.523 forever. So that's going to be 9.5%. Now we're at our last one, 3 divided by the 42 times the 100. And we get 7.142 dot dot dot. So we're going to say 7.1%. Now we want to add them to see how close we are to that 100%. So we do the 11.9 plus the 35.7 plus the 35.7, making sure I put my numbers in correctly. The 9.5 and the 7.1, and I hit enter. I get the 99.9%. This is very close. And it is good. Not bad, is it? Nothing's really bad. So here we're asked to analyze uh, a given relative frequency. The example are heights of adult males are known to have a normal distribution. Now, we haven't talked about a normal distribution yet, and I'll go further later on, but a normal distribution, because you hear it twice, it'll stick in your head, right? A normal distribution is referenced to the bell curve. All right, so what is a bell curve? Well, if we have enough data collected, then it is said from many, many trials that the more data you have, the closer to a bell curve you have. And that means that we have a low going to a peak high and going back down to a low with values and kind of symmetric. Not, like I said, the more the values, the more likelihood of a normal distribution. And there's more to it as we get further into this course. The researcher claims to have randomly selected adult males and measured their heights. So we're looking at a sample. We don't know what kind of sample, but a sample with a resulting relative frequency. That means percents. Distribution is shown here. Okay, identify two major flaws. So our first step is to add the relative frequencies. All right, so let's get our handy dandy calculator out. We're on the home screen. I'm going to clear everything and I'm going to enter the percents. 24 plus 25 plus 22 plus 28 plus 29. 24, 25, 22, 20, 29. Okay. I end up with 128%. 128% is more than 100%. Therefore, not a relative frequency. So we don't know if there is a mechanical error on the data or a transcription error. In either case, it does not add up to close to 100%. Therefore, that's one of the bobos. Then we notice what? What do we notice? We notice that the distribution of the sample is not a bell curve. So it's not normally distributed. So there's something wrong with the data collection as well. And all values are around 20%, which around 20%. Actually, 20% or higher. Which says that the data uh, also it's a problem. It's a problem. You can't say it's normally distributed and then that your sample is not very close to being normally distributed. So something is wrong with the distribution here. So those are the two things. All right. So here is a normal distribution. The data collected of the population studied has an appearance can't spell of a bell curve. That means oh, there we go. Sorry. That means the data starts low, rises to a high point, and decreases to a low again. So we talk about it like this. The data is more or less symmetric. It can be folded in the middle as a normal distribution. Now we'll go into details later about all the intricacies. So, does the frequency distribution appear to be a normal distribution using the strict interpretation of the relevant criteria? Okay, well, the relevant criteria says it starts low, but this is the lowest. So it is not a normal distribution because it should be rising slightly. Other than that, this is a high and this is a low, but this gap, the lowest, is 0, and it is the second count. So it is not a normal distribution. Well, this next example we have is a low, increases, so it's going like this to the 12 and then decreases. So it's got the low, the high, and back down to the low. Data displayed is a normal distribution shape. There you go. All right. So now we're going to talk about our calculator. Now, this is just a picture of what your calculator should look, and there's different colors and different items, but they're all the same keys. And I want to talk to you about those keys. This is called the home screen. This is called the graphing keys. Using these in a later section. And these keys right here are command keys. Using the stat key, and we're going to use the second bars key, and we'll be using some other items, other keys, but these two main ones are what we'll be using. And then right this clue here are operators to do math. Now, the number pad is like any other calculator, 0 through 9. It has a decimal, and it has a unique key of the negative key. So that's what the calculator is. And we've used it only for percents. We haven't done negative values, but we will in our studies run across a couple, nothing major. So what we want to do is learn how to enter data. So you're going to click on the stat key, and that's the second row, third key, to a new window. Then you're going to see the window shows edit highlighted and a menu, and the one needed is number 1 and edit. So you need to hit the enter key. You will view tables labeled L1, L2, etc. to L6 in some cases. If there is data on line 1, then up arrow under the trace and graph key. It's in the middle. Clear enter to erase data. Enter each data of the numeric values in line 1. Use only line 1. Second mode together, not together, but second mode. Both keys in a row, 1 next to each other, to go back to home screen. All right, now we want to sort it. Sort is to place in order. You can only do this to one line of data. If you have paired data, you don't sort because you mess up all of your collection. So now we want the data has been entered in line 1. You've done the first part, so it's already there. Then you go back to the stat key and the edit menu, and you select number 2, sort A, by enter. That's a command, is to enter. Will appear on home screen in ascending order, enter. This command will put it on the home screen. Then you do stat enter, display line 1 in ascending order. But after you do that, you have to do second one so that you can make sure that you have L1 sorted. It sounds hard, but it's not. So we're going to take care of that right now. All right. Take a moment to either take a picture with your phone or to write down the data, and so you can access it and work your calculator. All right. So we have this data, and the data is involving ages of actors, ages of actors, and these are a sample. So we want to get our calculator. Excuse me, I'm sorry. I've been talking. So we're going to hit our stat key. Our stat key is second row, third key. Second row, third key. And you notice the first is edit highlighted and number 1 is highlighted. So we're going to say enter. Okay, I want to arrow over to line 1 and I have data. So I'm going to up arrow and do a clear enter. I'm going to do the second one to erase it so you'll know what I've done. Up arrow, clear, enter. Now, I want to use line 1 so that all of us are on the same page. So we're going to enter the data. Does it matter how we enter? No. You can go horizontally or vertically. Either way, it's going to be the same. So I asked you to take a picture of it and you can look at your phone or put me on pause and do the work. So I'm going to enter the data and I'm going to speak while I'm doing it. 39, enter. 55, 20. Remember garbage in, garbage out. 71, 46. And I'm a good one about that one. 58, 49, 32, 48, 57. Oops, back arrow, 57. All right. So I've entered. Now notice it says 11, but the above it is 10. So I'm going to count 1, 2, 3, 4, 6, 7, 8, 9, 10. So there, this is 10 right here, and I am right there. And it looks pretty good so far. Now I'll keep going. 38, 48, 50, 49, 39, 40, 66, 53, 77, 34. All right, so now I should be at the next part is 21. And I look to see if I haven't duplicated or forgotten to enter a number and have an outrageous size number. Again, you must take your time on this one. So I'm on the third row for me. 46, 39, 43, 43, 31, 2, 49, 49, 33. So it should be at 31. I don't have any large numbers where I've duplicated or hit too hard on the key. 31, 64, and 38. So I should have, now that's 10, 20, 30, 1, 2, 3, 4, 34. So I should be on 35. Great. Now, to get on the home screen, I do a second quit. So no matter where you are, second quit is the second key and the mode. Second quit puts you always on the home screen. I'll write it down. All right. So now I want to sort it. Okay. So I'm going to do my step key. I'm still on edit and I see number 2. I'm going to arrow down to number 2 and I'm going to enter. It's asking me what line. So I'm going to do a second one and I see line 1 and I enter. It says done. So now I have the data in order. Okay, now why do I need that? Well, I'm going to show you on our chart. So now we're going to count numbers from 20, typo, oh my goodness, from 20 to 29, and so on, and put the number of actors of that age. So I'm going to hit Stat, Edit, and I can see how many. Well, you can see I have a 20, and it jumps to 31. So I have one actor in this survey that is between 20 and 29. On the 30s, let me see how many I have. 1, 2, 3, 4. Oops. Sorry about that. 2, 3, 4, 5, 6, 7. Sorry. I'm getting myself in the wrong dot. Okay, let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My goodness, I just can't watch and move, can I? Okay, I had 10 to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, went too far. And let me see if that one was, yeah, 9, 10, 11. 11. That's what I counted. Excuse me. I'm sorry. 40s. So let me move my 40 on the top. 1, 2. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13. Now I'm going to move it up the 50s, and I have 1, 2, 3, 4, 5. And then I have 60s. I have 1, 2. And on the 70s, I have 2. So we want the total. So we know we've addressed all of them in case I made a mistake. In this case, you have better eyes than I do. And I'm working on a screen. And the calculator is larger than this. So I have 34, which is what I said I had of the data, right? Yep, 34. So there is my frequency distribution. And you're saying that's a whole bunch of work, but we're going to be using it anyway. And the more practice you get at entering data, the easier it will be later on for me to instruct. So now we're talking about cumulative distribution. Cumulative means to add on to. So we start at the top and work down, adding the previous to the current. All right. So let's use that. Okay, so in our actors, I had, and here's the data for it, I had 25 for the first group. Then, and I should put it at the ends because I made plenty of room so I could put the math on it. So then I have 25 plus the next category, which was 35, which gives me 60. Then I have the 60 plus the 13, which gives me 73. Then I have the 73 plus the 2, which gives me 75. Then I have 75 for the 70 plus 2. Let me see, where am I? The 60 was the plus 2. Let me see what happened here. 25. 25, 60. See what I have? 25, 60, 73. Did I skip one? Let me see. 13, 2. Yes, 75. Okay. Up to the 70 would be the 75 plus the 4, which gives us 79. And then the 79 plus the 2 will give us 81, which reaches the 80 category. And the 80 category to the 90 is plus 2, which gives us 83 total. So we're going to add these frequencies to make sure that I have the correct value. And I have 83, so this is good. So my cumulative distribution is the last number is the total of the frequency distribution. Sorry, I cramped that in there. All right. So we're going to talk about understanding critical data and how it works for us. And we're saying reading for content, devising a plan, to arrive at a solution, just checking. So let's see what we can do here. Among fatal plane crashes that occurred during the past 65 years, 631 were due to pilot error. Um, 85 due to human error. Okay. 687 due to weather. And 203 were due to mechanical. And 74 were due to sabotage. The worst, right? All right. So, what are they asking? construct a relative frequency distribution. Okay, so we need our total of our data. All right, so let's get the data total first. I'm sorry. So I'm going to have, let me clear this because I'm working this problem, 631 plus the 85 plus the 687 plus 203 plus 74. Let me look at my numbers, 631, 85, 687, 203, and 74. So I have a total of 1,680 data collections. So we want our relative frequency. So let's talk about that. So we're going to have the 631 divided by the 1680 times the 100. And we're going to have the 85 divided by the 1680 times that 100. The 687 divided by the 1680 times that 100, because we want relative frequency. 203 divided by the 1680 times that 100. And the 74 divided by the 1680 times that 100. All right, so now we're going to do our math. I'm going to move it over here. All right, so we're going to do the 1 divided by the 1680 times that 100. So we're going to do 1 decimal place on the percent, and I'm going to have 37.6%. 85 divided by the 1680 is that 100 for percent. I'm of 5.1% using the rules of rounding. 687 divided by 1680 times that 100. And it's going to be 40.9%. I'm going to enter the 203 divided by the 1680 times that 100 is 12.1%. I'm going to have the small number here, the 74 divided by the 1680 times the 100. And we have the 4.4%. Okay, so we want to add up these numbers to see how close we are to the 100. So see if our math is good or fairly good. Remember, it's not going to sometimes be exact, sometimes not, higher or lower, one or the other. Always take your time with data. Haste makes waste in statistics, and I am a real good one about that. I have 100.1%, so it is good to go. All right, so now let's see what they want us to assess. What is the most serious threat to aviation safety? And we're looking for the highest percent. It is weather at 40.9%. is most serious. All right. Well, then it asks, can anything be done? Well, there has to be more attention, casting, and alerting pilots of weather changes. Now, what I'm saying there is the fact that if we have bad weather, they kind of anticipate the speed of change that's happening, but it can always variate with wind gusts and El Nino currents and things like that that cause things to accelerate or decelerate. I want to thank you for listening to me. This ran a little bit longer, but I wanted to finish it in a cohesive manner. Thank you. Do the homework.